Hey there, in this video, we will try to solve the LeetCode question number 1 to 5, which is of the valid palindrome. So here, if we check the question, we're gonna be given a string S, and we will have to return true if the given string is a palindrome and return false if it is not. So what basically is a palindrome? Here states that if we convert all the uppercase letters to lowercase and removing all the non-alphanumeric characters, it should read the same in the forward and the backward. Okay, so now let's try to break down the statements given over here. So basically, if we focus on this part, alphanumeric characters, so the range of the alphanumeric characters is from capital A to capital Z, small a to small z, and 0 to 9. So these are the basically alphanumeric characters, and these are basically termed as the alphanumeric characters. So there are not any special characters, and there can be both uppercase and lower cases. Okay. So so we will have to check if the given string is a palindrome or not. So for being a palindrome, the input should read the same from the forward as well as from the backward. So if we take a look in the example 1, which is this string, I have copied it over here. If we remove the space from here, the special characters from here, and then convert all these strings to lowercase, then if we just consider for the first 5 letters, because this is too long, for the first 5 letters and the last 5 letters. Okay, it should be up to P only. A, okay, okay. So here, if we just can write these letters in the lowercase, it should be A, M, A, N. So it is AMAN, and in the if we read from the forward, and if we consider this, and if we read from the backwards, it should be AMA. And A. Okay, here is one A also. Okay, so both reads the same if you can see. If we read it from the frontward, AMANA, AMAN, and here same AMAN, A. So if we also check for the remaining letters, we will find that all the letters will be reading the same if we read either from the front or back. So it won't be making any difference. So if you can see here, it's returning true because it is a palindrome, as it reads the same from the frontward as well as from the backward. So it's returning true. But if we look at the example, you will find that raise occur. It's just returning false because it's not a palindrome. So let's check. So here, if we consider this 4 from the front, it should be RACE, okay? But if we consider the last 4 from the backwards, it is RACA. So it's RACE and it's RACA. So it's not same. So that's the reason it's not a palindrome and it's returning false. So we're gonna have to design an algorithm which will detect if the input string is a palindrome or not. So we can solve this in a couple of ways. The first, which I'm going to show you, would be like using some predefined functions in Python. But the second one would be using two pointers method. So basically in interviews, I believe that two pointers method would be the best approach to go with, because many interviewers might have some problems if we are using some predefined functions in Python. So also the predefined function of the first one, first solution, which I'm going to show you, will take a lot of space considered with the solution 2. So let's at first go to the code of the first one. So For solving this using the first solution, which I mentioned, it should be at first we need to just declare a new string variable. So let's name it new s. So this is basically the string which is um, has all the alphanumeric characters. Like it eliminates the special characters or other spaces maybe we have. Then we're gonna use the for loop for C in S, so that we'll have to check if C is alpha. So here is alphanumeric is a predefined function in which I believe is also available in other languages like maybe Java. So this is a predefined function which can check if a string is a alphanumeric, sorry, if a letter is a alphanumeric or not. So we are just checking every letters in S means the given string, if it's alphanumeric or not. If it is, what we will be doing is we will be adding that to our new string variable. C. Okay. So we are just checking if the letter is a alphanumeric or not, and then we are adding it in the new variable. Another thing we are missing is we need to make sure that the C or the letter we are checking is in lowercase. So we can just use the function of lower, C dot lower. So this will check so this will convert the letter. Suppose there is capital A, it will convert it to small a and then add it into the new string variable, because it's stated that we need to convert all the uppercase to the lowercase for converting purpose. Okay. So after that, what we can do is we can come over here and return new as uh, if it's equal to. Okay, so this is basically the syntax for inversing a string in Python. So we are just inversing the new string which we are getting and comparing it with the old one we have, and returning if those both are equal. If those are both are equal, then it's definitely a palindrome, and if it is not, it will return a false, and that means that it is not a palindrome. So let's run the code. Um, oh, sorry, there might be a little bit of typo. It should be new as. Okay, so here you can see the three cases has been accepted. So here, what's the mainly the drawback of this solution? Um, Here, if you can see, we are declaring a new variable, so this is definitely gonna consume some space. Secondly, we are using two predefined functions, this one and this predefined syntax of Python. So these two might not be accepted in a real interview setting, and this is obviously consuming some space. So what could be a more better approach for it? So let's go to the solution number two. So here, suppose this is the string we are given. We can set up two pointers, one at the most left and one at the most right. So what we will do is we will check if the most left pointer has the equal character as the most right character. If it has, we will increment our left pointer by 1 and decrement our right pointer by 1 as well. So now we will compare if this character and this character is equal, but this is not an alphanumeric character. So we cannot really compare it with this one because it's going to be false anyways. So what we can do here over here is we can use our own alphanumeric function. we need to create our own alphanumeric function, which I'll be showing you in a few moments. What we can do is we can set up maybe a while loop, like while this is while it is not a alphanumeric, increment it by 1 as well. So now it's not a alphanumeric. So now again, the left pointer would be shifted to +1. So now the left pointer has alphanumeric character M, as well as the right one as also alphanumeric character M. Now it's going to compare. Uh, these both are equal. Now the increment will happen again. The left will be moved +1 and the right will be moved again -1. So in this way, we can just check from the 2 points of a string that if those characters are similar or not. So in this case, we are not directly inversing this string. What we are doing is in the given string, we are just comparing the first and the last element, and then going to the second and the second last, then third and third last. In this way, we are comparing to the string if it's a palindrome or not. Now, the question might be, when will we stop? Like up to when we will continue our loop. So we need to continue our loop unless the left and the right pointer meet together at any point, or the left and the right pointer comes to a similar point, which gonna happen if the number of letters is odd. So we need to stop in these two conditions. So let's code it up. But before then, let's see how we can detect the alphanumeric characters. Like space is definitely not an alphanumeric character. How can we make our own function to detect if a letter is an alphanumeric function, alphanumeric string or letter or not? So for that, we might need to take help of ASCII codes. So here is the ASCII table. So as you might know, ASCII assigns a unique value of each symbol. So here, if we can see that 0 to 9 has a ASCII code of 48 to 57. If you notice that all these are continuous, like from 0, 1, 2, 3, 48, 49, 50, 51. So these are all continuous up to 57. Similarly, if we check for the capital A, it's starting from 65, and all these are just capital letters. It starts with Z and up to 90. So these are all continuous as well, like 65, 66, 67. Similarly, for the small letters as well, here it starts from 97 and ends at 122. So here the ASCII codes are incrementing by 1. So it's all continuous. So we can use these ASCII codes to detect if the given string or the given letter is a alphanumeric or not. So how can we do it? Let's check. So what we're gonna do at first is set up our pointers. Okay. Before pointers, let's set up our alphanumeric detection function, which is going to be our helper function for this code. So let's write def. And now we're going to use the keyword self because it's in a class. And it's the maybe C. Then what we can do is in Python to get the ASCII code of a digit or a letter, we can use the ORD function. So we can write ORD A, sorry, should be within the brackets. Yeah, okay. ORD A less than uh, less than or equal to ORD B less than or equal to ORD Z. Okay. What we are doing is we are checking if the string if the letter or the thing that we are comparing is within the range of the capital letters ASCII code. As we mentioned, the ASCII codes of the capital letters are all incrementing by one, means they are continuous. So if the letter is in the range between them, we are checking it. Or we need now the capital part is done. Now we need to check for the small letters. So or basically, let me just copy it because it's gonna be similar. Let's copy it. So now let's make it these small letters. Now we are comparing it with the range of the small letters because we don't really know if given letter is a capital or not. So we are just comparing it now with the small letters. Now again we need to compare it with the digits like 0 to 9. So we are comparing it with the digits ASCII code. If these matches, then we will be returning true, else we will return false. So let's do it. Return. So we are just returning if the given letter or the special character we are comparing is within the range of the alpha, is in the range of the ASCII code of capital A to capital Z, or small a to small z, or 0 to 9. So we are just returning it. So now we have built our helper function. Now let's go to the main code. So let's define the left and the right pointers at first. So L should be our left pointer, it will be 0. Right will be our right pointer, which will be length, means the length of the S string which we are taking as an input, -1. The reason I'm using here -1 because the index um, of the string would be generally -1. So suppose this is the string. Here the index of the A is 0, M is 1. So this is the second letter, but its index is 1. So the index is basically 1 minus of the position of the letter. So we need to use len as -1. So this is our right pointer. So if I can show you in the figure. So basically now our right pointer is over here. So now our left pointer is over here. So here it's our right pointer. Now we can set up a while loop, right? Like while the left pointer is less than r, or means the right pointer, then we can check if as the index of L is not equal to as the index of R. Okay. If it's not equal, then we will just return false. Okay. Um, so we are checking if the if the index of L, like if the suppose L equals to 1, here L equals to 0, that means A. If A equals to the is not equal to S of R, that means R is now here A. So we are checking if A is not equal to A, then we will return false. But we are missing out on something, which is we need to also make sure that these are all lowercase. So we can just convert it into lower because a capital A, suppose over here it's capital and it's small. So it's gonna return false even for it, because these won't really work if you don't convert it to lowercase. So it's now converted to lowercase. For that, we need to make sure another thing. We need to make sure that the letter or the character we are comparing is an alphanumeric. So it should be, sorry, that's a simple type. So we need to again make sure that the letter we are comparing is an alphanumeric. For it, what we can do is we can set up another while loop, like What I am trying to do over here is if the letter we are comparing, suppose this space is, if it's not a alphanumeric, then increment the left pointer by 1, and if our right pointer encounters a non-alphanumeric character, then decrement it by 1. So I will do the exact same thing over here. L, sorry, of num, we will be using the S. Okay. So if the letter in the left pointer is not a alphanumeric, what we will do is we will increment it by 1. Sorry, we will just increment it by 1. And the same thing for the right pointer as well. Just L and not alphanumeric equals to, it could be R, and we will just decrement the R by 1 so that it can just go to the next value to compare. So here we'll just checking we have added this so that the left and the right pointer doesn't bounce back without the range, and then checking if it's not a alphanumeric, then increment it, and if it's not a alphanumeric in the right pointer, then decrement it. Okay, so up to this it's all done. It looks good. Now we're gonna have to do the last thing, which is incrementing the values upon each compare. Suppose here the return was not false, like in this case it's it's all similar. So now it's not false. What we will do in this case? For this case, what we will do is we will um, just increment values. Um, L should be L plus 1, and R also should be R minus 1. Okay, so we are taking if not false, then if it does not return any false value, means it's similar, like in this case a equals to a, then we will move our pointer to the next values, like we will increment our left pointer by 1 and the right pointer by minus 1. Okay, so at last we're gonna just return true if all one's good. If this range becomes void, like the pointers are crossing each other or in the same place, then we can just return true, means it's a valid palindrome. Now let's just return true over here. It looks good from it. Let's reduce this space. So one thing I'm just missing is we need to use the self over here as well, because it's under a class, and if under the class we need to call a function, we need to use the self. Because it's the function under the same class. Okay, now let's try to run the code. Um, okay, so it does seem to work. See, the 3 cases was accepted. Let's submit it and check. Okay, it does work without any issues. What's the main intention of this is we are not using any extra memory. Like in this case, the memory, we are not saving it anything or not initializing any new variable. So the time complexity will be, sorry, I mean the space complexity will be O of 1, because it's a constant, because we are not saving anything or using in hash map or something like that. And the time complexity will be O of n, because we are just iterating through the array only once using 2 pointers from both the sides. and we are just we are just iterating through the whole array only once, so it's gonna be in linear as well. So it's definitely a better approach rather than the solution one. But yeah, over here the time complexity is also an ideal one, and the space complexity is also like in constant time, which is more than ideal, I believe. So these are the two solutions we can use to solve this problem. I hope you might have learned something new on this video. So yeah, thank you for watching.